Good day, everyone. Today we are solving polynomial equations. Before we begin, couple things. First 9 weeks end on October 14th. You do have a quiz at the end of this week. Check Google Classroom even when absent. You guys should always check Google Classroom. It is your responsibility to go there to check for important information, stuff that I may drop little bonus points here and there to help you out. I need for you to be on top of that at all times. All makeup work that includes optional work is now closed and no longer will be graded. And these are the assignments posted from the 5th of August till the 15th of September. So that's all closed. Makeup work from the 16th to October 1st will be closed on October 2nd and will not be graded afterwards. And I will be posting that. I posted some this weekend just to see who was going to, take the hint. Some didn't, most didn't, so I just decided to close on out. But I was throwing a little more. But remember, it is your best interest to stay on top of that, to take care of this makeup work that I'm throwing at you guys to help you out. You guys will have a 3-part test in the week of October 3rd. So that week of October 3rd, we're going to be doing just that. The last week of the first 9 weeks, you're going to be having a mock ACT, and then you're going to be dealing with ANET. All right? And for your mock ACTs, if you manage to score a 18 on the mock ACT, mock. If you have an F in my class or a D, you will end up with a C if you score that 18 or above. With 18, that is. If you get to a 21, if you have a C and less than a C, a 21 will give you a B for the course. 25 and above, of course, that's an A for the course. And that's for the mock ACT. But do not forget, because it's a mock ACT, you are not out of anything. You're not out of homework. You're not out of tests either, because it's a mock ACT. Also, your ANET. If you happen to score decent on your ANET, that may be a way to help you pass the course if you are failing it, that is. But ANET will also be contributed to part of that test stuff that I'm talking about. All right. Take this moment to check your grades. While you are doing so, any concerns must be addressed through a private chat or email tiara5@ebrschools.org. Meet with me third block to discuss. I can't and will not discuss those grade concerns for no longer than 5 minutes. Attending and tutor online Monday, Wednesday from 3:30 to 4:15 is a good way to help out. But please be aware, if you are after 15 minutes late, there's really no point in coming. I won't allow you to be a part of it or give you credit for it. Recall how participation and grading is done in my classroom. Remember this, during that last week of the first 9 weeks, there's no makeup. There's no makeup work I'm giving. There's no late work I'm accepting. So make sure you have your stuff together before that last 9 weeks here, because that's my testing, my grading period. That's why this week, that's where you're going to know exactly where you stand. All right? So again, do not come to me during the last week of the first 9 weeks. Ask me this, that, and the third. The answer is going to be no. Wait till everything is graded for you to know where you stand at. So, no makeups, no nothing. ACT reminders. When you take the real ACT, 18 will give you no test. But you gotta be responsible for homework and classwork and projects. If you get a 21, you're not responsible for tests nor homework, but you're responsible for classwork and projects. Please, 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 please do not think that having those two scores means that you get to chill and kick in my class where you could just text your girlfriend or boyfriend all day in my class. That's not going to work. Also, those who are continuously being on your phones while I'm going through the lessons, it is going to hinder your participation grade. I need for you guys to put the phones in your pocket, put them to the side, and focus. You can't understand something if you're not paying attention to. Tutoring is happening today. Monday, Wednesday, 3:30 to 4:45 online. Go Google Classroom for the link. Adhere to my tutoring rules. Don't come in acting crazy or think you could just chill and just not do anything and get some tutoring points. That's not going to happen. All right? So if you got that mindset, it's not going to go. Throw you out or not give you credit. You just going to sit there think you're going to get credit, but you will not. All right? So adhere to those rules. And of course, earn some makeup points. Some of you guys going to need some points. Get some extra added to your test grade. Add a little points to your test grade. Tutoring does that. And again, before you come to my tutoring, adhere to all of my tutoring rules. I will have that posted the first seconds you guys join in. And do not forget, if you are more than 15 minutes late, I can't have you in it because that's not enough time to get you what you need to be at. All right, let's go back to some factoring. By now, we had a day of review with factoring, so we should be at a level of proficiency at it. And that's if you put in the effort to try to do it. If you have not, well, best of luck to you. So what is the greatest common factor of the first expression? The first one to the left. So when you factor this, the greatest common factor is 4x. Nicely done. Okay, if I put out 4x, what's going to be left on the inside? X minus 2. Nicely done. How can you tell your answer is correct? Still to probably check your work. 8x. It's not 8x. So 4x times x is 4x squared, not 8x. 4x times negative 2 is negative 8x. And that's how we check our work. So of course the dots in the triangle format means I'm finished. Alright, so what about this guy? X squared minus 121. Ooh, wow, that's been a while. How will we factor that one? Well, I know that this dealing with perfect squares because 121 is a perfect square of 11. So, because this is a difference of squares, I'm going to have an x plus 11 or x minus 11. And to check my work, I could just distribute like so, distribute like this. X squared minus 11x plus 11x minus 121. All right. So that cancels out x squared minus 121. And that's how I know my work is correct. All right. Again, you forget the difference of squares. Go back to a previous video what we did for this lesson, because in today's lesson there's gonna be a lot of stuff that we have factored, and it's gonna come, and we're going to work with those things that we already factored in the past, and that's a few new things too. All right. How do I factor this guy out? The first one to the left. Well, I know that that's a 3, so that means I'm dealing with cubes. Because I'm dealing with cubes, I know that 64 is not cube root of 8. 64 is a square of 8, not a cube of 8. Well, we know what is a cube. We know 64 cube is of something, which is going to be 4. So t plus 4. And remember, you got 3 t's and 3 4's. I know my t's ain't right, but alright, okay, so in the first parentheses, t plus 4, so I took one of each. Now when I do my second parentheses, it's going to be t, because I'm taking 2, t squared. Alright? What's going to be in the back? 4 squared is going to be in the back, which is 16, but we say 4 squared, that's fine, but I like using 16. And it's positive. Minus, I got combine 1 4 and 1 t, which makes 4t. So let me rewrite this for you guys. 10 plus 4 t squared minus 4t plus 6t is my final answer. Again, if you are struggling to understand how I got that, please review the lesson that I have of cubes. Alright, so let's factor the problem to the right. My greatest common factor I have of this is 6x. And when I pull out, what am I left with? X cubed minus 3 plus 4x. And of course, we can always check our work, but well, let's do it because I want you guys to get in the habit of doing it too. So 6x times 6x cubed is 6x to the 4th power. All right. 6x times negative 3 is negative 18x. 6x times 4x, that's incorrect. That doesn't give me 12. So let's go back and fix this. So 6 times what gives me 12? 2. Nicely done. That's why it's very important to check your work on all of this. And that's how we know that our answer is correct. So when we pull out the 6x, and then we use distributive property to put it back, that's how we know that our answer is right. Again, this is the reason why I prefer to check my work back, because that's how I know if I got stuff right or wrong, because sometimes even I get it mixed up a little bit. All right. Alright, y'all. Now let's get to it. Solving equations in 3 methods. So listen up, y'all. All the factoring and stuff we've been doing, it's gonna come into play. You're like, oh, okay. Because that's essentially all we're doing. We are factoring, but we're just taking it one step extra. Alright? So let's just review equations right quick before I move on. So if I was to say solve this equation, how will I solve it? What's the strategy behind it? You have to get x by itself. So to do that, I got to subtract 1 on both sides. I get 8. Then, from there, I got to divide both sides by 2. And that's x equals 4. Alright, so if you got that, that's the additional step that we're going to have to do with polynomials. Alright, what is the precise definition of mathematics? It is the technique to explain, understand, and manage reality specifically by ciphering, counting, measuring, classifying, ordering, inferring, and modeling patterns arising in the environment. Towards the end of this 9 weeks, we are going to finally model patterns arising in the environment. Remember what I told you there's 2 types of math? 2 types. Abstract. That's the stuff I've been teaching you guys. That's the stuff with all the X's, all the thinking, and all the stuff going on to it. And then the other math is called the applied math. That's the stuff that everyone likes because you get to take the math and apply it to a real life situation, such as dealing with money. Everybody loves money. All right. M-A-T-H. What do that spell? Mistakes allow thinking to happen. Mistakes allow thinking to happen. Mistakes allow thinking to happen. So what that means, y'all, because some of you guys don't quite understand this definition just yet, that means for everything that I gave you in this class, it's imperative that you try your best on it. Even if you don't know it, you fake it till you make it. You leave nothing blank on my test, quiz, or anything I give you. You do not say, I don't know. You do not use any of that kind of Debbie Downer stuff. When you are trying, you are giving me effort. You are talking to me about the subject. You talk to me about the lesson. You're not fussing about, oh, this too much. Oh my God, it's too much. When you do that, that's you forfeiting. And that means by you forfeiting, I got a right to go in my grade book on you. Remember, people like us have no choice but to work. We can't fail. We can't complain. We can't just be like, I just give up. You can't afford that. Remember what school we are all at. We just can't afford that. Ustruma cannot afford to give up. You cannot give up. All right. Now, let's get into it. This is a definition that is very important for you to keep with and know. A polynomial equation is the result of saving two polynomials equal to each other. An equation in general form if one side is 0 and the polynomial on the other side is in descending powers of the variable. The degree of a polynomial equation is the same as the highest degree of any term in the equations. Here are three examples of polynomial equations, such as x plus 5 equals 0. That's one. And that x has a degree of what power by itself? 1. And this coefficient we know has a variable with a degree of power 0. So what about this guy? X squared plus 5x plus 6 equals 0. That's one with a degree of 2. We could keep going, but I think we're going to just leave it enough of that. So I gave you two examples. Well, I could do one more. X cubed plus 2x squared plus x minus 3 equals 0. There go another one. So I gave you three examples of polynomial equations. And again, those degrees are in descending order, such as 2, 1, and 0. Remember, a coefficient always have an exponent of 0. So let's go look at the cubic function. 3, 2, 1, and x of 0. That's what it's saying for the polynomial equations. Alright, let's go dig deep into it. The zero product principle. If the product of two algebraic expressions is 0, then at least one of the factors is equal to 0. So, if a times b equals 0, then a equals 0 or b equals 0. Alright, so before we can even get to all of that, how do we factor this? We see 64, we see an x squared, and then negative 81. So what do we know? We're going to be dealing with the difference of squares. So that means we know that 64 is the square root of 8, or a perfect square of 8, and we know that 81 is a perfect square of 9. So let's do it. And don't forget about your x. So because this is a binomial, we're going to have two factors, which are eight x minus 9. And then we're going to have 8x. For some reason my A ain't working. Plus 9. Miss Howard, why you space those apart? Why you spacing stuff apart? Yeah, I got my reason, and you're going to see it in a moment. Again, these are the factors. What's inside the parentheses are called factors. Alright, so to solve this equations, because you have two of them, you have to do the following. Ax minus 9 equals 0, and then 8x plus 9 equals 0. Alright, So let's go ahead and get this together. So before we go ahead and get it together, you see how both of them equal 0? This is the zero product principle. As the product principle says, if two product of an algebraic expression is 0, then one of the factors is equal to 0. Both of them are equal to 0 in this case because we have a binomial with the exponent of 2. Because the exponent is 2, you're going to have how many solutions? 2. Or 2 answers. So let's solve them. So let's go to the left. So if I add 9 to this side, I get 8x equals 9. And then if I divide it by 8, and my answer is going to be x equals 98. So you know me, I like to do my little triangle symbol. So that means I'm finished. So let's do the other side. So subtract 9 here. Subtract 9. Equal 9 x divided by 8. So I get negative 9/8. So I know how some of you like to simplify. You like to make it 1 over 1/8. You don't need to do that. I could do it 9/8. That's cool. So guys, this is your final answer. Again, this is the zero product principle. So we just factor in it, set them equal to 0, and solving for x. That's all we're doing. And I forgot to tell you guys, but this is method A. You're going to have 3 methods. And remember those cases that I was telling you that we did before? You're going to see those too. As how they work in these 3 methods. So again, this is method A. All right. Wait a minute. That looks familiar. You bet it's familiar because you know why? Because you did it before. You did it with me in class. All right, y'all. So let's go ahead and work this problem out. So going back to what we did in class and the previous lesson, what case is this going to be? When we factor, what case is this going to be? Case 3, swing method. Mr. Howard's favorite. All right, so we know, going back to that, also, if you got your homework or your notes from last class period, you could flip back to that if you got it already, and you could just copy and paste your answer. So, you know from last class period when we did this, we knew we did swing method, and we multiply front times the back, and we get x squared plus 33x plus 32. And we know when we factor, again, I'm going to separate them the way that I did in the previous example. You can get x plus 1. That's plus 1, y'all. And then x plus 32. Now, again, because it's a swing method, you know you got to take this 8 and divide both of them by 8. And so so let's look at the first factor. Do you get an integer when you divide 1 and 8? Nope. So you got to swing that bad boy to the front. 8x plus 1. What about 32 divided by 8? That does give you an integer. So no swinging there. X plus 4. Now you got to set them both to 0. And let's just solve. I'm sorry for being quiet. So at this time, you divide here. You get x equals negative 1/8. That's one of my answers. So let's look at the right. Subtract 4 for both sides. Subtract 4 for both sides. X equals negative 4. And that's my other answer. So negative 1/8 and negative 4. All right. That is how you deal with that. All right. So which cases these two problems resemble? Going back to last class period. If you don't have your notes, you should have at least watched the video of that lesson. Because again, my videos are no different than how I teach the lesson in class. All the difference is you get to ask me more questions. I wish this was live. It would be nice. So I could ask questions on the spot. All right, so let's do it. So we know the first one looks like case number 1. I mean case 2, not case 1. Case 2. So we know that when we get our two numbers, they give me negative 5, which is 1 times negative 5 gives me negative 5. So we know that. So we already know our factors. So no need for me to do this because I know for a fact that I'm going to get negative 4. So I know my numbers. I know my factors. So let me erase and not waste up space. So x plus 1, x minus 5. Right? And you don't have to put the parentheses for the factors at this step. You don't need to. You just need to know that those are your two factors that you need. They give you back the original problem when you use your for method. All right. So x plus 1 equals 0. So subtract 1 for both sides. You get x equals negative 1. So let's do x minus 5 equals 0. Add 5 to both sides. I get x equals positive 5. So that's my answer for that one. All right. So let's look at this other problem. Again, the problem to the right. Again, these are problems that you work with me in class or you did for homework or came from that previous video. So these are no surprise. All right. I'm not throwing no tricks, no nothing. And that's the reason why I gave you guys so many problems to deal with, because those same problems got so many components to them. Last course period, we're factoring them. Now we're solving their equations. And you're going to see them again when you graph the solution. So again, same stuff. So let's get to it. So for the second problem, we get what? That's case 4. That's dealing with them squares because I know this because I got 9 and 1. 9 is the perfect square of 3. And then 1 is a perfect square of 1. But one thing that I need to pay close attention to, I got a negative in the center, but positive in the back. So that means I'm going to have two negatives as factors, 3x minus 1, and then 3x minus 1 here. But you know they look the same, right? Because they look the same. And you could put them together and use distributive property. For the method to get back to this guy here, but I prefer not to waste time, especially with someone I know I'm right on. Anyway, so because you got them to be exactly the same. So you gotta only do this once. 3x minus 1 equals 0. So when you solve this, add 1 to it, add 1 to it, 3x equals 1, divided by 3, divided by 3, x equals 1/3. And because there was 2 of them, you could just repeat it twice. 1/3, 1/3. I would be cool with that. That is your answer. So again, when we are doing with case 4, depending on how the trinomial looks, you may have the same equation twice to solve, but you could write it once. Right? Oh, so there's a question about these trinomials. All right. Before we continue, let's look at these trinomials very closely. We know them as their cases, but I want to look at them very, very closely. So I'm erasing my answers. I'm doing this for a reason. Because I know some guys are struggling with the factoring the trinomials. And I just want you to understand it a little bit. So let's look at the equation, the expression to the left. The trinomial to the left. So you see how I got 2 negatives here and here? Because I have 2 negatives, that means my final answer, I should have something that looks like this. X plus some number, which is a, x some number, negative number. But in this case, I know when I multiply those 2 numbers, they gotta be a negative number. I'm writing in letters because they're just negative numbers. And when you see those 2 negatives in a trinomial, that means you multiply 2 numbers get negative. But when you add them, or let me take this back, when you add them, one of them is going to be a bigger negative number versus the small one. So A in this case is a bigger negative number. A is a bigger negative number. And Z, I'm just saying Z, is a smaller positive number. So in this case, negative is big. So that means when you see those 2 negatives in that trinomial, when you factor in, one of them is going to be a big negative and the other one's going to be a small positive number. All right, let's look at the one to the right. So the one to the right tells me this, that my middle term is negative. Trying to use yellow. My middle term is negative, but my back term is positive. So that means that I have 2 negatives. 2 negatives. So that means that when you multiply those 2 negative numbers, negative n times negative c, you get a positive a. Again, those letters are just any numbers. But if you add negative plus another negative, you get a negative b. I know no one cares for the abstract because it's too many letters, but again, the letters represent any number you want to choose. All right. Let's go ahead and get through the last example of this. Again, I'm only addressing those who are struggling with these trinomials. So what if I have something that looks like this? X squared plus 1x minus 6. So what should my final answer should be? So we know that two numbers multiplied together gives me negative 6. But those same two numbers got to give me my positive 1, which is 3 times negative 2. 3 plus negative 2 is positive 1. So that's x plus 1. X plus 3, x minus 2. In this case, you got a big positive number. Big positive when you have a plus in the center and a negative in the back. All right, I just want you guys to get an understanding of that. All right, method number B, the square root property. All this saying is when you have a square root to the side, you're going to have two answers, a plus or minus, or if the square root is negative, you're going to have two answers, but they're going to be imaginary. I means it's not real. So do me a favor. Put in negative 6 in your calculator. Your phone calculator, whatever calculator that's nearby. The square root of negative 6, see do you get an answer. No, you won't get one because it's not real. You get an error because it's not real. It's imaginary. And we did imaginary numbers before. It's not real. But you don't have to review them too much, so that's the reason why we ain't going to talk too much about them. All right, method B. All right. So if u is an algebraic expression and d is a non-zero real number, then u squared equals d has exactly two solutions. Exactly two solutions. All right. And it's going to be either u with a positive d or u with a negative d. But then if u squared equals d, then u equals plus or minus d. Again, if it's negative, it's imaginary. And you're right, just like this. Negative square root of 5 is I, because of that negative you pull out, and square root of 5. All right. So, this looks familiar still. You darn straight it's case number 1. So let's go ahead and do case 1 then. So, from case 1, and again, look at your notes from last class period, because we did this one. We know we factored them in groups. Let me be careful with that. For the first binomial, you get x squared with x minus 2. And then in the second binomial, you get 5 with x minus 2. And we know when we factor, we put the stuff that we pulled out in the first factor, x squared plus 5. And then what we have left is x minus 2. So I'll separate these for a reason. So you can put them together if you want to. You can put x plus 5. You know what? Let me just do it. That may confuse some of you guys. So x squared plus 5, x minus 2. All right. Again, you don't have to do that. You could just separate them like this. All right. So let's do this. Minus 5. And we subtract 5 here. We get minus 5. Oh. With the square root of 2. Oh, that's a minus 5 though. So you take the square root of both sides to undo it. To undo a square root is the way to undo it. But notice I got a negative 5 in the square root, so x equals negative square root of 5, which we know cannot happen. So we got to pull that negative out, and when we do, it becomes I, but don't forget about the rules. You have two solutions. So this is going to be plus or minus I, because you took it out, square root of 5. So that is how you do that. All right, so let's look at the other one, the other factor. So the other factor, you add 2 to both sides. You add 2, x equals 2. And that was easy. So these are my answers. So x plus or minus I, because I had a negative 5, I pulled out the negative sign to make it I, imaginary 5, which again 2 solutions, and then I had this x equals 2. So how many solutions I had in total? I had 3 solutions there. And how I should be able to find out is because look, x to the power of 3, the leading exponent is 3. So that's how you could tell how many solutions do you have. So I got x plus or minus I5, square root of 5, or x equals 2. All right, I'm going to erase this sum because I need space to work the other problem out. Wish there was an erase all button here. All right, let's look here. So here, Polynomial groups, I could do this. So I get x squared, x plus 6, and then because on the second one is negative 2, do they have in common? I didn't ask about the greatest common factor, I just jumped into it, did I? So when I take out the x minus 2, I'm left with, when I take out the x, when I take out the negative 2, I get x plus 6. All right. Now, of course, you can put them together. I choose not to. According to an easy solve. So if I add 2 here, and then if I take the square root of both sides, which again, square root and square they cancel out, I get a square root of 2. So because it's positive, I'm going to have x equals plus or minus square root of 2. Because 2 is, square root of 2 is positive. I got 2 solutions there. And then let's do the one to the right. So if I add 6, I'm going to subtract 6 here. Subtract 6 here. X equals negative 6. Let me rewrite that in a different color. I think someone got a question going on. So why is x equals negative 6 and there's only one solution? Well, here's the hint. X is the exponent of what power? 1. So you got one solution. Here, you got x to the power of 2, 2 solutions. And then going to your leading, going back to this one with the leading exponent of 3. So you got 3 solutions. So again, your problem, your expression is going to tell you how many solutions you can have. Are they going to be real when the square root is positive or imaginary when the square root is negative? But you're going to have 2 of reals or 2 fakes, or imaginary as we call it. All right, method C. Now, method C, the quadratic formula. This does go back to Algebra 1, so you probably have forgotten about it. But I got you. Hopefully, if I sing for you, maybe you could catch on to it. This method is for those who are not good with using the swing method, which is method number 3, or who struggles with method 4 with the squares. Well, not the squares. The squares are very easy, but this works best for cases 2 and 3 if you're not good at factoring, or if it's unfactorable and you know you can't factor it. So do not forget, if the square root is negative on the inside, that means you're going to have plus or minus. Because it's dealing with squares, you're going to have an imaginary number. You're going to write it like that. All right. So the quadratic formula, the solutions of a quadratic equation in the general form ax squared plus bx equals c equals 0, with a cannot equal 0 is given by the quadratic formula. X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. Don't hate my singer. I know I have a beautiful voice. All right. So this guy here, that's the thing that ultimately going to tell me what kind of solutions I have. So if n is positive, the square root is positive, I'm going to have 2 real solutions. If this is 0, I'm going to have 1 solution. Or if it's negative, I'm going to have 2 imaginary. All right. So this does resemble the swing method, but I know for a fact when I do the swing method, this is not going to work, because if I was to rewrite this, x squared minus 6x plus 2, I can't think of no numbers. Multiply it together gives me positive 2, and then when I subtract them, give me negative. I mean, when I add them, give me negative 6. That's no way. So here's what we do when it comes to problems like that. Ready? Get your voices ready. I know it's annoying, but I promise you, you're going to remember this by heart. Yes, this is something that they do on ACT. Ready? Set. X equals the opposite of 6 plus or minus square root 6 squared minus 4ac all over 2a. All right. X equals the opposite of 6 plus or minus square root negative 6 squared minus 4 times 2 times 1 all over 2 times 2. Leave me alone. I'm a good singer. All right. Enough. So we know that negative 6 squared is saying negative 6 times negative 6, which we know is positive 36. So we get 36 minus 8, which 2 times 2 is 4. So let me ask you this question. Thirty-six minus 8 equals what? That equals 28. Again, the plus or minus is telling you that you're going to have a positive and a negative. That's just how anything to a power of 2 operates. All right. And you rewrite it like that. Now I'm going to erase a little bit because I need more room. All right. Good. So we was left with 6 plus or minus 28 over 4. So before we continue with that 28, because you got to learn how to break down these squares into primes. Like for example, 20, we know that this is, you could write this as square root of 5 times square root of 4. And we know the square root of 4 is what? 2. And we don't know anything about 5. You just do that. And that's what you're going to do for 28. 28 is going to be the same thing. So let's do it. 28. We get the square root of 4 and the square root of 7, which we know the square root of 4 is 2, and we get 7. All right? And this is just my scratch work. You don't have to do that. You don't have to write the way that I did. That's just something that I did to kind of understand that square root of 28 could be broken down. So this is 6 plus or minus 2 with 7 left over in the square root over 4. Okay, so 6, 2, and 4 have a 2 in common. So when I simplify that, I get my final answer of 3 plus or minus the square root of 7 over 2. All right, let me erase that. And again, that's just, you may want to keep the quadratic formula down to memory, because on your ACT, listen up, for ACT, you will not have a formula sheet, you gotta commit that to memory. All right. All right, let's do our last one together. And we will be finished. All right. So there go the formula. X equals the opposite of B plus or minus square root B squared minus 4AC all over 2A. All right. Are you ready to do it with these numbers? X equals the opposite of 5 plus or minus square root 5 squared minus 4 times 1 times 2 all over 2 times 1. Just like that. I know that's a little sloppy. I could clean that up. All right. So let's do it. 25 minus 8. I'm working in the square root over 2 plus or minus negative 5. All right. So when I simplify all that in the square root, I get the square root of 17 over 2 plus or minus negative 5. Again, when you're dealing with anything with the exponent 2, you're going to have a positive and a negative side. All right. So let us finish this. All right. Again, I'm rewriting because I got no space. So let me ask you this. Can this be simplified? Does negative 5 and 2 have anything in common? And can we find a perfect square within 17? A number times a square equals 17? Nope. You can't think of one. 1 times 16 is 16. It does not equal 17. 1 times 17 is 17, but 17 is not a perfect square. So guess what? This is your final answer. And that's it. All right.